Hello, everybody. My name is Brad Culberson. Today, we're here to talk about observability for Snowflake data applications. I work in the field CTO office. So if you do ever talk to me, some of you may have already met me. I work with customers every day to help them build applications on top of Snowflake.
Hello, everyone. I'm Lakshmi Kumaraju. I go by KLP as well. I'm a senior lead software engineer, Capital One Software. Capital One Software is an enterprise B2B business of Capital One.
The agenda today, we're going to start with what is data observability, kind of give you a little bit of background there in case you don't have a lot. Mostly it's an overview. I'll hand it over to KLP, which will talk about Slingshot data processes and observability, which is actually real world application of what I talk about. And at the end, I want to talk about Snowflake's current observability tools, what you can use today, and then also what's coming soon. To start with an overview, this whole part of the market, I think, started around this first. And a lot of people were building software, and the first time they knew something was broken was when customers reached out and said, hey, my application isn't working. And I think people realized that wasn't a great customer experience, and your team should probably already be working on it before customers tell you that something's broken and not working. And at least then you can respond in that response and say, hey, my application isn't working. And to that inquiry, you can say, our team's already working on it. We already know it's not working, and also be up quicker. The foundation of this, I think there's three major things that are usually put together to add monitoring and observability into your application. There are metrics, like numbers on systems, structured logs, which is much more detailed information around what's happening in your application right now, and traces, which are most commonly used for performance and knowing how well something's going in extreme detail. Health checks are super common inside of observability, and health checks allow you to do simulated load. So if you anticipate customers have certain behaviors, you can write tests that continually iterate on that. And you probably do that in pre-production environments already, but you can also run those same things in your production environment to know that the production environment is healthy. Also, I would include dashboards to this. So a lot of those numbers, the metrics and the structured logs can be used to then visualize this and show what is your current performance of your system? How is it behaving? Is it healthy? Is it hitting your SLO? So your service level objectives, as they're defined, are you hitting those and targeting those? And how have those changed over time? And definitely SLAs. So if you're contractually obligated to meet a certain number, you should probably know what the number is inside your production systems. And you should know when you do software deploys and when you bring online more users, if that's getting closer and closer to that and whether you need to spend more energy there. After the dashboards, I think that's as good for if you have people that can open up dashboards and look at them all day. It's not super efficient. So often the dashboards get added to also with alerts. So if people aren't opening the dashboard and looking at it, they still get notified and say, hey, you're actually approaching your SLO, your SLA. You need to come online to actually look and see what's happening with the system. Or it's unhealthy. It's actually not working. You should have your teams come online with that. Customers usually tell me that's a lot. I don't know where to start. We don't have anything. Where do we focus? I like to focus on the customer experience because that's what this naturally came from before. Customers say, this thing I expected to work is no longer working. Customer experience is the first place I would start. So what features are they expecting? Can you test those? You can test those through synthetic or real user monitoring, looking for errors and other things to know if it's behaving well, and then alert your teams and have dashboards around those. If they have certain expectations around performance, it's a good thing to set SLOs on to know what their expectations are, and then also make sure you have some insights into that through dashboards. Definitely on SLAs, making sure if you do have an SLA that you do have that plotted, monitored with dashboard so you know whether you're approaching on it or not. I like talking about smoke versus fire. You don't want the alert to be the first time you say, oh, look, this whole system degraded, and then you look at it and it's actually slowed down for the last 12 months and no one really looked at it. This observability, I think, is something we see happening more and more in applications, especially things that are customer facing, less so for internal. But is there telemetry that helps you here? So we talked about customer behaviors. What are they expecting? There's also other just system information that can also give you signs of whether something's healthy or not. This may not be customer behavior. It may be things like actually telemetry coming out of our systems. So we're here to talk about Snowflake, so I'll be very Snowflake specific here. Things like queries per second on warehouses is something you should probably know for all your customer facing workloads. And you should probably have dashboards on this and know historically what these look like and how they're changing over time. Things like query performance, how those have changed over time is also super important. Aggregations, are how often are tasks and queries succeeding and failing? Do you have query queuing happening on warehouses? Are customers waiting longer than they did before? And also the number of active clusters and how credit consumption is behaving. All of these are things I would anticipate starting on. And at the end, I'll talk through exactly where you can find these inside of Snowflake and how these are available. But I just want to kind of call out some of the things you should think of when you're trying to figure out what is the generic observability you should be adding. I'm going to hand over to KLP now. He's going to talk about Capital One software. Super excited because this is a real world use case of what we're talking about.
Thank you, Brad. On data observability and the cloud. With Snowflake now enabling us build real-time data applications, we had to learn how to build monitoring and observability into our application that was built on top of Snowflake, which has complex data pipelines along with some data moving across multiple Snowflake accounts. Today, I'm here to talk about how we implemented data observability in our first product, Capital One Slingshot. Let me tell you what is Slingshot and why it exists. Back in 2017, we began moving our data to cloud, and we needed a partner who can better manage and scale our data ecosystem. I'm glad we chose Snowflake as our cloud partner. Snowflake provided us great power that enabled our data engineers to move swift and build features that generate a lot of value for our Capital One business. But with great power comes great responsibility. So we built Slingshot to help optimize our costs and reduce and eliminate any inefficiencies in our warehouse performance and accelerate time to value by speeding up Snowflake adoption. All of this under strict governance and regulatory requirements. I'm excited today to share about some of the critical features of Slingshot that helped in maximizing our Snowflake investment. Starting with cost insights, a quick review of dashboards provides opportunity to optimize your costs. And the next feature, warehouse scheduling and recommendations, provide optimized schedules for your warehouses, and it provides much needed elasticity to scale up or scale down, both horizontally and vertically, right? So that you're running your warehouses only as and when required, based on your workloads. And several other automated workflows that helps you maximize your investment in terms of running the workloads in an optimized fashion, right? Behind the scenes, we run a lot of data processing to support each of these features. Let's understand how our data processes look like. Slingshot being a B2B SaaS product, we onboard and support tenants from multiple Snowflake accounts running on different cloud providers. Our tenants run on AWS, GCP, and Azure. We perform tenant-side processing of metadata and move either share or replicate data into our primary East AWS Snowflake account. Tenant data is replicated and then maintain a tenant-specific data store, and we run our data pipelines on a given schedule so that we aggregate the data and push it to a central Slingshot data store. Features apply their own transformation and input validations and make the data consumable by Slingshot. Our Slingshot web application runs in a separate AWS account, and our tenant users log in from web to check the data or the features. So from the data engineering perspective, we use streams, tasks, stored procedures heavily to perform data transformations based on policy requirements and any other input validations that needs to be performed. If I take a look back at our journey, the architecture when we started our partnership with Snowflake is more around standing up a database, perform the data load, and turn it to our analyst community, where they used to run millions of queries, and then that provides a lot of business insights or values. But with Snowflake continuously releasing features like streams, tasks, pipes, and our close partnership with them has enabled us to build an architecture that supports a real-time application. I'm sure many of you here have recently built or soon be building real-time or near real-time data applications on Snowflake. And if you are, in the next few slides, I'll be going over Capital One journey from the landscape of observability. What are some of the challenges we ran into, how we went about solving them in terms of observability, and what are some lessons learned in this journey? Let's dive into that further. The case for observability, right? From the previous slide, we can see that there is a lot of activity happening in different Snowflake accounts. It could be in Slingshot Snowflake account or in our tenant Snowflake accounts. And there could be multiple processes running within the Snowflake account and data moving across accounts. For a system like this, there could be multiple places where things did not work as planned or as designed. delivering data with quality and on time is always Slingshot's mission. So we came up with 3 important steps to live our mission, starting with detect, like I also call it as proactive data monitoring. We want to be able to monitor the health of different processes running within Slingshot, which are running on top of Snowflake, right? So for example, did all my pipelines completed successfully? It helps in understanding the data freshness within your system. The next one we will check is, did I receive right amount of data in terms of number of columns or the values? It helps in understanding data volume running within your system and data quality within the system. And did all the pipelines complete within the SLA? It helps in maintaining your contractual obligations, right? If we detect any problem in any of these areas, the next step is to be able to notify or surface the issue to right parties who can address it. It's critical to inform right parties at the right time so that issue gets addressed in an optimal way. Once it has been surfaced, the next step is to be able to act on it. Action could be acknowledging the notification, and it could be flashing an update to your product health status page, or it could be sending a customer note communication saying that something got affected, or it could be as well as restarting a data load job. The customer success teams and engineering teams should have enough tools to be able to trace the issue and be able to act on it. Acting fast can help remediating the issues in an optimal way, as well as improving your customer satisfaction, and helps in maintaining the contractual obligations that Brad was talking earlier, like SLA, SLO, and MTTR. The lower the MTTR, the better for your product and for customers. When I say customers here, it's both your internal customers, which are engineering teams, as well as your external customers who are your end users. Let's look at what are some of the things that Slingshot uses to understand the health of the system holistically, right? We look for stored procedure failures to understand the failures that are happening and being able to act on it, which happen as part of your data transformation or data validations. Stored procedure execution times to understand if there are things are taking longer than expected. Tasks, like tasks have multiple statuses like suspended and cancelled. A cancelled job could indicate that it did not get enough resources to complete its assigned task, and a suspended task could indicate that you have potentially performed an altered task and it's never resumed. Data freshness, like being able to understand or being able to detect that data loads are delayed. Either it could be because of our upstream taking longer or your internal processor taking longer than expected, but being able to surface it up and then communicating with your stakeholders is critical. The next one is Snowflake object access failures. Like we often can resonate, like we have deployed a stored procedure in production and it failed for access privileges. It hasn't been provided necessary privileges or grants. Object access history. Data security is utmost important for us and for everyone. Snowflake provides multitude of tools in this space, starting from masking and access privileges and so on. But being able to detect an unwanted batch ID trying to access columns or data that it is not supposed to and surface it up acts one more layer of safeguarding for us. This is the baseline set of indicators that we use to understand the health of the system. But as we learn more, we keep on adding further. And we use 2 primary sources of information to gather these metrics. One is our application-specific logs that we maintain and store. Second one is a rich set of metadata that Snowflake provides in their information schema and account usage schema, like views and tables from those schemas like query history, task history, object access history. Brad would talk more on those in his part of the session. So we did a quick analysis of an existing system that could actually help us in the space. We did not find anything that we could readily use. So we went ahead and built a system, and our system was built with following design tenets in mind. The first one is standardized logging. Logging is a basic building block of observability. Unlike other ecosystems which have like robust logging frameworks like Log4j, stored procedure world didn't have anything. So we decided to go ahead and build a logging module of our own, which comes a standard set of fields, like log level, log ID, query ID, and then push that to a central log store. We have made it flexible enough for our engineering team to be able to capture the messages like how many rows got affected as part of a statement, or if you want to capture particular transformation as failed, that information can be pushed as well into the log store so that we can inspect and act on it at a later point of time. The next one, design tenet, is configuration driven and self-service enabled. We want our monitoring to be simple, extensible, and configuration based. We maintain our configuration in a Snowflake table, and we use 3W configuration, which is which table or view has the logs, and what's the threshold that you need to monitor for, and who needs to be notified if the threshold is breached. And in order to be able to engineering teams to quickly onboard and offboard configurations as required, we built several self-service tools, and we have gone to an extent like these tools are integrated with our tenant onboarding. So if a tenant is onboarded, like we know if there are certain alerts that needs to be configured for them, we have integrated them into our product onboarding process. The next one is this engine, which is a critical piece of our monitoring framework. It goes based on the configuration to different log stores and then looks for threshold breaches. And it serves as an orchestrator. It's implemented as a stored procedure wrapped in a task, basically. And it supports both schedule-based as well as event-based reporting. The next one is being able to integrate with existing tools. We want to focus on the things which are necessary or most required to be built, and being able to integrate with other ecosystem existing tools like PagerDuty and Lambda. So we use PagerDuty heavily for maintaining our production support schedules for other applications. So we want to be able to integrate with those. The next set is being able to observe multiple Snowflake accounts. Slingshot, being by its nature, has operations in multiple Snowflake accounts across different cloud providers. We want to be able to detect patterns if the issue is happening within a particular Snowflake account versus region, versus the issue is happening across all the Snowflake accounts, so that you are able to triage it appropriately, being quickly classifying it as local versus global. And other bells and whistles, like being able to suppress the alert based on the configuration, as well as being able to onboard a set of alerts whenever a new stored procedure or a new task is getting onboarded into our platform, basically. With these design tenets, we have built our monitoring system and deployed into our production. Let's go through a quick example how it works. Let's say we want to get alerted if it is more than 24 hours since our daily load job ran. Our monitoring stored procedure as part of step 1 picks up the configuration. Remember, our configuration is based on 3 steps, which is which table has the logs, and then what's the criteria that we are looking for, and then which team or individual needs to be notified. So in the step 2, our daily logs are pushed to a central log store, and the criteria it would be looking for is the difference of current timestamp and the latest runtime of the daily job. If it is greater than 24 hours, we push a entry into the notifications table. A Lambda sitting in a separate AWS account picks up the notification and triggers a PagerDuty. The PagerDuty is again configurable based on the team or the individual supporting that particular job, and based on the channel-specific configurations, the alert gets delivered to either Slack, mobile, or email. So some of the benefits that we reaped out of this solution is basically after initial deployment of this solution into production, after initial couple of weeks, we have 50 plus self-identified issues, and because of that, we were able to maintain our internal SLO within our product. We were able to detect and address performance issues before they go out of the hand. And we have about 100 plus alert configs today from 6 different feature teams, and we are still more counting. We are able to support it as our product scales. And some of the design decisions, like being able to integrate with existing tools, has helped in adopting our framework easily within our teams. And coming to the lessons learned as part of this exercise, the custom log library that we have built has provided much initial liftoff. Without that, we wouldn't have been able to alert on our transformation failures or data validation failures that we use JSON format to maintain the dynamic logging, but it comes with a challenge. Snowflake has an object limit of 16 MB. Today, we don't run into that, but as our product scales, that's something we would keep an eye on. But if there are existing log frameworks, we would definitely be migrating towards that. And In order to store the logs, we use regular Snowflake tables, and Snowflake tables have a write concurrency limits. If multiple stored procedures are trying to push the logs at the same time, we would probably hit the write table concurrency limits. So we have some workaround in place in terms of limiting the number of times stored procedures as part of their execution, writing the logs, which leads us into our final or the third one. So because we accumulate the logs in the stored procedure execution and push it as a batch into the central log table at the end of the stored procedure execution. Because of this, in edge cases where your stored procedure is abruptly terminated, then you don't have any logs to go after. So these are some of the lessons. We hope our journey could help other businesses to build robust observability into their own applications. And thanks for this opportunity. Brad would now talk more on how Snowflake is bringing new capabilities in this space that could address some of the pain points for customers like us. Welcome back, Brad.
Thanks, KLP. It's super cool seeing what people can build on top of Snowflake. We've been talking to a lot of customers around observability, and as they're building applications, trying to figure out like what capabilities can we make and how can we solve for a lot of the difficulties builders have today. First part of this last section I want to talk about is what's available today. What can you do immediately tonight if you decide to add more observability to your app? Then towards the end, I'll talk more about what's in roadmap right now and what is in preview. First thing I would highly suggest you look at that's available right now for you is information schema. This is access to close to real-time information about how the systems are performing inside of Snowflake. We provide all the data necessary to be able to build a lot of this observability and monitoring and alerting on top of Snowflake, but nothing's built for you. The data is just sitting there. So you'll have to come up with your own business rules for what does it make sense to alert on? What is my threshold for when I need to show it in a dashboard versus alert a team versus page someone on call to come online? These tables are the ones I see most commonly queried by customers. Query history shows all your queries, whether they've succeeded or not, what their timings were. Task history shows the task successes and failures through history. Copy history shows if anything came through a copy statement that failed to load and maybe never got loaded. Automatic clustering history, I think, is important. If you're using that service, it's really wise to keep a monitor on credit consumption as well as success or failure of that. Pipe usage history is also super common. There is a plethora of tables inside of here. These are just the ones most commonly used. I'm not sure exactly the count, but there are many, many tables in here. What I would look for is what features in Snowflake you're using, and then look for the tables inside of here to figure out which ones you should be adding more dashboards onto, as well as adding monitoring. Account usage is the second level of this, and these are a little bit more delayed. So these are much better for usage for trending and these long-term aggregations and dashboards on this. The ones I love is warehouse events. This tells you when warehouses are brought online, when they're suspended, where they're taking offline. So they can start showing you health of like, are your suspends set properly? Or are they too aggressive? If this table's full of warehouse resumes and suspends, I would probably review that policy and figure out if maybe you have too aggressive of a setting, right? If that changes over time, also, why is that system behaving differently? Why do you have more clusters online now than you did 2 weeks ago? Hopefully your end users are you have more volumes of end users or a new feature got developed, but you should be watching this because this directly correlates to efficiency as well as costs. Query history is also one I like to see here because you can look for long-term trending of queries. Often customers will say, oh, I think my queries have gotten slower over time. I'm like, well, you could have a dashboard on that and you could look at exactly what they've done over time, right? And if that is trending towards every month your queries are getting slower, it's probably pretty smart to look at that before customers start calling and it falls off the edge. So all that data is available. Access history is one that KLP mentioned. I think that table is incredible. Many databases do not offer this kind of capability. We show what objects are getting accessed by what users. Very good for security use cases to say, I think we have the proper RBAC set up, but maybe you don't. This is a very good way for security teams to build observability into, are people poking into data they should not have had access to? And it's a second check on what's happening inside of Snowflake. All of these are immutable data stores, so you cannot be concerned with anybody inside of Snowflake or any of your teams mutating any of them. They are pinned-only data sets and no one can touch them. There's many, many more of these also. These are just the ones I think are most commonly used by customers. KLP mentioned several pain points they had. I think I'm at least excited that we have some things coming into preview right now, so we're starting to get into the upcoming features. He talked a little bit about Log4j and how logging hard in Snowflake today. We definitely agreed, and we saw many customers having this challenge. Event tables is the first thing that you can look at. This is currently in public preview, so you can use this in your production accounts right now. What this allows you to do is log data with your current libraries that you like to use. So if you're in Java, you could use log4j. If you're in Python, you can import logging. Something very familiar to you. You can import it. You can set your logging levels. I have a demo later that shows this actually working in production. The other thing that changes with this, with event tables, we're not using our traditional storage formats for this. So KLP mentioned a lot of concerns around contention and how Snowflake's oriented for large batch operations and analytics and bulk loading. Used to seeing little tiny inserts happening with high concurrency. Event tables have a completely different backend. This backend allows for heavy, and high utilization, high events per second that are getting persisted inside of Snowflake. This is all built through serverless compute. You also get charged for storage in this. But I think it's been very, very exciting for me because it's allowing you to add observability into your applications in a more natural way, not in unnatural feats, which that had to be done by many, many customers. The second piece that got built to help customers is this alerts and notifications. This is also public preview right now, so you can go and work on this immediately. Alerts are a way to get notified when anything inside of your data set actually meets conditions that you defined. If you can write a SQL statement to find some error in the current system, you can create an alert on it. So all those tables I talked about later, all those query performance things and task errors and copy errors, all of those, you can write a SQL statement and define how many of those errors are going to cause a threshold where you think it's a concern, and you can choose to alert based on that. So alerts look very, very similar to our tasks in Snowflake. The difference is it automatically executes SQL, and when it finds records, it automatically does some action. And I will show that in the demo of exactly how to use this. The most common actions we see customers using are email notifications today. KLP mentioned they use PagerDuty. We see a lot of customers using PagerDuty. I love that software. You can integrate that through email notifications. It automatically routes it into their system. You could also have this trigger an external function, which would call the Lambda, which would also hit their API. So you can do multiple ways of doing this. Email notifications are just built in. So I set this up during the demo, but this can either email a person or some other system. And then you can create some downflow from that based on your requirements. These do execute on a warehouse, and I will show this. It's very, very simple. It's just SQL. Let's see how successful the video is today. Awesome. So first thing I'm going to start off is just doing an insert. So this is a data pipeline where I'm inserting some bad data. And a lot of production systems, some bad data gets in and they completely break. In this, you see this. I just inserted 12 records into this. It's a bunch of JSON data landing inside of a text field, and I'm going to transform that into a destination. Now, line 124 is pretty interesting. That does not look like valid JSON to me, and it's not. That would break almost everybody's pipeline that exists. Line 125 found a day in February that was the 29th. I can assure you that's definitely not a date, and that would also break almost everybody's pipeline. What I did is I created an event table. You can just see it's create or replace event table. You name it. You can put it in any database you want. You then alter your account to use that event table, and you set your logging level. That's as much as it takes at the account level to turn on logging. Now you can use your existing logging libraries and all your stored procedures and functions, and it'll automatically log to that table. There's the import logging. Let's log some warnings. Here I caught the bad JSON data. I caught the bad date data, and I'm logging that. I decided to actually ignore those records and log them, so the pipeline will continue getting all the good data, but all the bad data will land into that log table. Every time this runs, it tries to import all of those, it truncates the landing area, and then it continues. That's how you create a notification inside the system. You can see it's emailing me whenever there's actually a problem later. This is how to create an alert. The alerts, you can see I'm querying the events table. I'm looking for that warning message that's in the try-parse ticket, which was in my pipeline for parsing that data in the landing area. When that's found, and the try-parse is broken, it's going to email me. It's going to say some lift tickets have bad data. Go look at that. I ran this earlier, so I inserted all this data less than a minute ago. So all this pipeline's been running in the background right now. The ingested data table will have 0 records because it's been imported. So 12 records are now gone. Hopefully they're in lift tickets. 10 records in lift tickets. 2 were bad because of the bad data. We can now look to see when did the task run. The task run is right here. So the task actually ran properly. That makes sense because the data showed up in the destination table and was no longer in the current table. The alert history, I'm looking for triggers. That would mean that an alert went off, which should be these bad records. Here we go. We found one. And you can see the SQL they actually ran and everything, which I like. Then let's look at the events table. So what data actually got inserted in from all that logging framework? So we should see the bad data in here, as well as the bad JSON, and actually attach all the data in here. So you can see all the bad JSON data is sitting in there. The bad data is in there. So someone could come in and triage this later and say, okay, why did this break? What should I do with that consumer? What should I do with that data? That's it. I just wanted to show you guys basically it working in action. I definitely suggest going home and playing with these. These are all documented. They're working really, really well now. I'm super excited for them, and hopefully it'll make some of your alerting and notifications a bit easier. The last topic I want to talk about just for a moment is native apps. So this is probably the first time that you guys have heard so much about native apps at this year at Summit. We're super excited about this, but also we understand that this is 100% running inside of Snowflake. We have to provide all the observability tools for you, because the only things you can run inside of native apps are Snowflake things. The application framework itself, it's now available. It's preview, but you can also start using this in Amazon right now. But people building these applications have to, bolt these things together. And what are you going to be able to do? I suspect the event tables that we just released are going to be commonly used inside of this. It's probably a very, very good thing to think about of what type of logging messages do you want to come in? What information do you want to know from your end users? What do you want to know that's succeeding or failing? When something fails, what details do you want? What I love about this and what we're building out right now is this to be available to both consumers and producers. So as a producer, you're writing all this code, you're instrumenting it. Whenever you actually deploy that into the customer's account, which native apps you build as a provider, deploy into a consumer's account, you're deploying that code, you wrote it, you can instrument it the way you want. We are providing consumers access to those logs. It then can be opted in to be shared back to the provider. So you as a provider can also see the exact same information. So you can now build monitoring and notifications on the same systems. Today we went through several subjects. We talked a little bit about data observability at the beginning, kind of as an intro. We were lucky to have Capital One Software here to talk about what they did to solve these today. And then we went into the future in Snowflake. Thanks for your time today. We really appreciate it.